Good afternoon, everyone. I am pleased to introduce our work titled Alleviating Hallucinations via Supportive Window Indexing in Abstractive Summarization. The theme of our study is to improve abstractive summarization, the task that condenses a lengthy document into a shorter version while retaining only the most salient information. The recent mainstream technology is to build systems based on language models pre-trained on large-scale corpora. It involves reformulating the summarization task as a sequence-to-sequence language modeling problem to facilitate fine-tuning the used model with a maximum likelihood estimation objective. Despite being simple and versatile, many previous studies pointed out that abstractive summarization models supervised learning with MLE are prone to produce hallucinatory content. It is because MLE enforces a model to remember certain language patterns from massive previous instances rather than to capture the semantics of a given text. To this end, existing approaches commonly compensate for MLE with additional learning objectives that maximize the semantic coherence of a document and its summary. However, the required unsupervised or semi-supervised learning scheme results in an unstable and expensive model training. Having seen this background, we attribute the generation of hallucinations by neural summarizers to their failure to locate and set the key facts contained in an input document. Also, we believe a poorly supervised learning framework is encouraged to ensure stable model performance and a moderate training cost. In a summary, we make the following contributions in this work. First, we propose to explore an evidence-based text generation mechanism to alleviate the hallucinations faced in abstractive summarization. Second, we realize our idea in a supportive Windows indexing grounded summarization paradigm, and we train the resulting Swigs model with only supervised loss items. Finally, we conduct extensive automatic and human evaluations to prove the superiorities of Swigs in improving summaries of faithfulness and human likeness. Specifically, compared with the traditional summarization approaches, Swigs exhibits significant differences in the instance format and modeling objective. On the one hand, we split a document into several continuous chunks through a sliding window, which has a straight half of its size, and we prefix each trunk with an index token to facilitate it to be cited. On the other hand, given a summary sentence, we define its supportive windows as the trunks in the source document that achieves a relatively high textual similarity score with it. Our Swigs paradigm requires a model to orderly generate the index tokens of supportive windows before producing a coming summary sentence. This slide lists key conceptions used in our method to facilitate reader reference. We designed three types of loss functions to train our Swigs model in orthogonal aspects. The first part follows the standard MLE, which trains the model to predict the modified summary conditioned on a formatted document. Also, a label smoothing mechanism is used to avoid deterministic token distribution. Then, to ensure the index tokens inserted in the input document correctly indicate trunk supportiveness to a summary sentence. We propose a logistic regression task named window confidence prediction and introduce a cross-entropy loss over heuristic binary labels. Finally, to ensure the index token of a group of supportive windows are correctly set at the decoder end, we propose to align the encoder and decoder hidden spaces. This is achieved by minimizing the KL divergence between heuristic label distributions yielded from the Swigs encoder and decoder. We conducted experiments on CNNDM and XSUM, and we compared our method with 7 recent representative methods scattered into 3 categories: vanilla pre-trained summarization models, factual-aware methods, and current state-of-the-art summarizer. We use automatic metrics to access the generated summary lexical quality and faithfulness. Also, we invite human volunteers to evaluate faithfulness, hallucinations, and information integrity. In our automatic evaluation, Swigs achieves the overall best performance on both data sets, and it improves summary faithfulness without damaging human likeness. Case study shows that Swigs is able to focus on the crucial parts of an input document, which contributes to the improved faithfulness. Human evaluation results also demonstrated that overcoming groundless generation is a reliable way to reach faithful and human-like summaries. Finally, we perform comparative experiments to decide the best setting for our sliding window mechanism. We find that a too large or too small window damages Swigs performance, and using overlapped windows is a better choice. In this work, we develop an evidence-based text generation technology to enable faithful abstractive summarization. We implement a supportive windows indexing mechanism in the standard transformer, and the resulting window, Swigs, shows apparent superiorities over comparison methods. That's all of our report. Thanks for your attention.